Welcome to the webinar, Secure Your Continuous Delivery. We've got a ton of great stuff now. Sorry for having that technical glitch. Let's get started. I'm Pete Chargan. I'm your host today, but I'm not the star of the show. The session today is 30 minutes long, and we are recording the session. Please stay to the end. There will probably be a bunch of questions from both panelists and from attendees, and lots of value comes from those sessions. If you send in a question, we'll do our best to get to all of the questions. OpsumX is here with a mission of helping you deliver software without any human intervention at all. We have some products, especially OpsumX Enterprise for Spinnaker, that helps you secure your software delivery. We have global customers all around the world, and we're a leading contributor to Spinnaker. Again, we don't want to spend too much time on that. What I'd like to do is get a little bit of information about who you are. And so I'm going to launch a poll. Oops, pardon me, that's the wrong one. I'm going to launch the poll, the correct poll. And I'd love to have your input into your situation. How secure is your continuous delivery, your software delivery, and are you using Spinnaker in that effort? While you're answering that, I'd really appreciate it if everyone went ahead and answered those questions. I'd like to introduce our two speakers today. Our first speaker is Gopal Damadi. He's the CEO and founder of OpsumX. He's been in the software delivery area for quite some time. You may very well have heard him speak at conferences, tech talks, etc. Our other speaker is Funds, and Funds Kesson is the Chief Security Architect here at OpsumX. He has been involved in a very large number of enterprise security implementations over a long and illustrious career. And he has also been the Chief Security Architect at AWS. So he has a ton of value that he can add here. Waiting for a few more people. Well, this is interesting. We got to exactly an even number. You should be able to see the results on your screen now. One person or 1/4 of the people say that we're not very secure. About 40% of the people say that there's a little bit better than that. And about 40% of the people say pretty good, but not perfect. And some people are using Spinnaker, and some people are using Jenkins, and some people are using another CI tool for software delivery. So that's the background of the people. What I'd like to do now is to get going. So Gopal, I'd like to toss it over to you for the first question. What are the key aspects of secure delivery?
Thank you, Pete. Think about delivery, and I think Funds can speak, give an additional color. To me, there are three aspects to securing delivery. One is, the first and foremost is that securing the CD process, which is essentially guaranteeing that the artifact that is to be deployed, that gets deployed, is the artifact that is supposed to get deployed. So all the RBAC, everything is in place. The second aspect is assessing that the risk within the artifact itself, and ensuring what is deployed is secure. And today, people do a bunch of things to make sure, a lot of security scanning, etc., to be done to make sure that that is true. The third aspect is what I frame as observability, auditability, and insights. Essentially, can we prove or ascertain that the delivery process is secure and auditable? And if something were to happen, is it possible to trace back to the source of the problem? And so those are three pillars. And there's obviously, all of this comes with best practices and policies, etc. Now, the way I think about Pete, can you go to the next slide? Yeah, so if you look at the delivery process today, especially at scale and speed, security becomes a very big challenge. There is there's an orchestration that we do during delivery. That means you have pipelines, you have multi-cloud deployments, and then there is the intelligence sort of a problem, which is at every stage in the pipeline, there is some gatekeeper, and you need to make sure that the person approving is actually the right person, he's getting the right data, etc. The second is at various stages in the process, there's a risk verification that needs to happen. Somebody looks at test data or during deploy, logs and metrics, and within that itself, you could have security sort of issues that are unearthed. And the third would be the fine-grained policies, making sure that what gets checked in doesn't go into production without the right policy checks. And the fourth is once at any time, you want to make sure that your artifact is sort of certified in some sense to be in production. And when in production, if there's a problem, how do you try to trace back? Right? All of this gets complicated when the scale and speed of releases increase, which is increasing for everybody. Everybody wants, as we talk to customers, we see that most customers want to have at least one or two applications that they want to release faster. And the scale of release is increasing. Let me sort of talk about how we are thinking about, just give you like a little bit overview of what OpsMX does as a platform, and then I'll give Fons to kind of comment on that question. Pete. Yeah, so at a high level, the platform that we have is a secure platform. Essentially, we have two layers, which is sort of a Spinnaker layer here, and Pete, if you bring on the yellow, the next slide, yeah, the whole thing, yeah. We have this yellow layer, the ML policy. This is sort of what we call the intelligence layer, and the below is what we call the Spinnaker layer. So essentially, the blue solves the problem of can the artifact get securely delivered, and the green and the blue, greenish blue, deals with can I make sure that this artifact itself is secure, and we provide an observability layer on top. That's what sort of we do, and that's the stage. And we have Fons, who's more of a domain expert here. Fons, do you want to add some color to what I said?
Yeah, well, I think it's interesting. If you take those three domains where you say, well, the base of the platform needs to, adhere to certain security standards that people have, typical things like role-based access control, but also making sure the containers themselves are secure, so people can meddle with what's going on in those containers themselves. So, there's an audit trailing aspect there and a control aspect there. And then when you move up to the greenish and azure kind of color, you get into, am I delivering a secure workload? Does it adhere to the standards that I want to apply to it? And the interesting thing we see is that a lot of people have these elements spread out throughout their organization and different responsibilities in different areas, but they're not glued together. And I think, to the point Gopal was making earlier, is like what we see is people want, faster is the new fast. People want speed, and they want to have more control over the release process. And because of the bifurcation we see in organizations, that doesn't happen. So if you can bring this all together, you actually give people the possibility and the ability to accelerate their deployment cycle and their delivery cycle and give them more control over it. Because the bifurcation of all these responsibilities also makes it very, not very transparent to people what the actual issues are. So if we zoom out a bit, what we see is there's a security organization that checks, for example, a artifact or checks artifacts, and they do that on a monthly basis. And then they create tickets based on those artifacts. Wait, we have artifacts with security issues in them. But these artifacts already ended up in production. So they're behind the fact. And what we're seeing is that people really want that integration and really want that cohesion where you know before you're deploying something if it adheres to the standards you have. Now that kind of comes into the third layer, the observability inside an audit, right? So how do we trace something? How do we find something? How do we know that it is what we say it is? So making it easy for people to find those elements. So we're seeing that the whole trailing and tracing capability kind of folds into attestation and controls. So that's a really important component there.
Kopal, you're on mute.
Yeah, thank you, Fons. You want to go to the next question, Pete? So Fons, let's give me a color on sort of some of the best practices and frameworks we encounter. And obviously, I set a frame saying that, hey, there are these three sort of areas of making sure the delivery is happening securely, what is delivered is secure, and we have observability. Give me a color on sort of what are the best practices and frameworks in a nutshell.
So if we look at best practices and frameworks, I think a difficult thing is that there's a lot of vendors that are calling what they do a framework, which is kind of like, which is a difficult conversation to have, right? Because a vendor is obviously saying, hey, my product does this and blah, blah, blah. But if you look at it in an abstract way, there's a couple of people that wrote really good documentation on this. I mean, the Devops automated governance architecture, that's a really, really strong document. And it's done by a group of industry leaders together with John Willis, one of the founders of Devops, who's working for Red Hat at the moment. He's doing a bunch of stuff around automated governance. And the thing that people kind of forget is that security is an implementation of what governance wants. And that's a really important thing. So knowing what the company needs and what the business needs and projecting that in a way that is tangible for security from a security perspective is really important. So it's really cool if you try to do everything all the time and make everything as secure as possible and plug all your servers, but eventually that's not going to bring the business. So it's very important to kind of go through the aspect of what do we need from a governance perspective, what do we need from a certification perspective, what do we need from an audit perspective, and then see how that kind of rolls into your security play. And that actually needs to go into the automation you do around it. And I think that document is a really valuable document because it talks about attestations of controls. It talks about all those things and how you implement them. There's a reference implementation for it as well. Then the automated cloud governance from ONUG is a really good document as well. I think everybody should read continuous delivery reliable software releases through build, test, and deployment automation from Jeff Humble and Farley. I mean, it kind of outlines what pipeline thinking is and why you should be doing this. I mean, they wrote their own tool at some point, and it's a commercial tool. You can buy it. That is what it is. But I think the book is very important because they came from a world where they were doing this in practice. And it talks about how you gain trust in the pipeline and how you built that out and kind of how that works. The other one that's really good is the DoD Enterprise DevSecOps reference design, but it tries to boil the ocean a bit. So if you're only interested in software delivery, it's kind of like, it's a lot to take in. So it's like, you want to skip some parts and kind of zoom in on that. Yeah. And this obviously has some resources, but they haven't put it all together yet. So they're working on something, I think. And as far as I've seen, they've not really put it together. I might be wrong there, but that's kind of where they are. I think one of the key things, however, that people tend to forget is it's about observability. So if we talk about security, if I'm not seeing it, I can't have an opinion on it. So, that's one of the key things. So everything you do needs to have a tangible output, or which leads to a control and attestation, or leads to an action. If you don't have actionable outputs or outputs that are an attestation, they're useless. If you don't have any attestations, you don't have any guarantees that the controls you have are actually real. So that's one of the key things there. So focus on maximizing observability. And the other thing is security of your pipelines themselves, obviously. And for us, that's inherent to the way OES works. But for a lot of people, they don't even put it in GitHub or a version S3 bucket, and they don't even audit what's going on there. It just lives somewhere, and people click around and it changes things. So making sure that those pipelines are secure is a really important thing. And then what we're seeing is that policy as code is becoming really popular. People are trying to kind of grappling onto that, and the notion, something that started with OPA and Styra. We see Sentinel from HashiCorp, which is kind of embedded in Vault now. We see people doing their own. But policy as code means that we define what the rules of the system are around the system in an abstract way, while the system can do its job, but we're observing the system and telling the system, no, you can't do that at certain points in time. And we'll get into that a bit deeper later on. But that's kind of the two things I think are important. And then if we talk about leading with the conceptual process, what we spoke about earlier, we see that companies have a lot of these things in place already, but they're very, very scattered. And so you take that process and you start looking at how do we automate that process as quickly as possible in as small as possible chunks with all the players participating together. So that's kind of what we mean with lead with the conceptual process.
Thank you, Fons. I guess the next question to you would be, how and where do one start? Again, the way I think about it is, as you are, when I talk to customers, I put them into sort of DevOps maturity stages, as in there are people that just do Jenkins-based deploy. There are people who use sort of pipelines. Essentially, they have automated workflows. Then the third stage is people who do deployments, deployment strategies. Then there's a fourth stage, which is sort of very security conscious, compliance conscious. They have security compliance as code. And the fifth stage is kind of like the Netflix of the world. They're continuously delivering at every minute of the way, right? Obviously, it depends on where people are, but the way I think about when I talk to CIOs, the way I frame it is you need to think about it from, are you trying to secure your pipeline? Are you trying to secure a delivery? You need to absolutely secure a delivery and think about all the RBAC, etc. And I think you can give some color around it. And then, how do you get your make sure that your artifact is secure, and then the observability. So where does people start? Do they start with observability, or how should people think about this problem and move them to the next level of where they want to be?
I think your observation about the layers, with Valhalla at the top, I think that's a very good observation, because I see the same thing, right? The DevOps maturity. I mean, it's you've got people that say they're doing something and are doing. And some of them are not doing anything. There's even a layer below that where nothing happens, and then you've got the layer that you mentioned, Jenkins, and you build it up. And I think most of the people are below half of that. Like 90% of the companies are below half of what we're talking about. I mean, if we're observing in the market, right? There's a couple of people that are really, really at the top, and those are the examples people take. Like, oh, we need to be like Facebook, we need to be like Google, we need to be like this company, we need to do what they're doing. But it's very hard, and getting there is not something you do in a day, right? That's kind of the issue. So initially, you create a plan, and the plan needs to be very simple. You need to have a very simple goal, and it needs to be small. Think in small chunks. You need to chop it up in small chunks, because if you're like, we're going to automate everything, it's like, okay, but what is everything? And you need to describe everything, and it becomes a very complex thing. So what we're seeing is that most companies that we work with, and I've worked with in the past, you start with small chunks. You start with the low-hanging fruit and the simple things that are hard to do by humans, that are relatively easy to automate, but are cumbersome for humans to do, because you want to take the humans out of the equation, right? The humans make mistakes. They have a bad day, a bad morning. They do a typo, and they break something, or something goes wrong. So the initial onset is that you create a plan around what are the repeatable processes that are easy automatable, that take a lot of effort and time today. And those are the ones you start with. So for example, we have a customer that uses Terraform, and they had SREs doing manual Terraform deploys, and it would take them a day or 2 days to roll out certain aspects of their platform. So that was one of the first things we took and said, okay, we're going to take that away from you, and we're going to automate that. We're going to take that away and put that in a pipeline, and we're going to make that simple. And now they can push button, or actually automated deploy that same thing in an hour, instead of an SRE sitting there for 2 days and figuring out what he's doing and running different scripts and different things. So I think it's about taking tangible things and automating them. That's where you should start. And the awful thing usually is that security doesn't come into that. security is like, a lot of people are like, security, let's not inform them about, let's park that for later. And I think one of the things that we're going into in like the second part is that you need to put responsibilities where they belong. And that's something we tend to see as well, that the security group is not informed or involved initially. They get involved later, and then they have an opinion. And it's great that they have an opinion, but they're not putting their fingers on the keyboard. And this is, I think, a general issue we see. We've got architects, we've got security people, we've got all these people running around. And eventually there are two people with fingers on the keyboard doing this stuff. So it's very important to put responsibilities where they belong. And I think this is also part of the DevSecOps movement, that security needs to put their fingers on the keyboard and actually do something. So, and this is great about the pipeline world, right? Security can actually insert something there and add meaning and add something profound to that system. But that is what we see in most successful companies, is that everybody participates in building that pipeline instead of having one group of people doing that. So I think that's a very important thing. So distributing the workload and making sure people have actual items for the outcomes they need to have. That, which brings me kind of into the next step, right? So if you look at actionable outcomes for the system you're creating, which folds into what I was mentioning earlier, if you have a system that creates output, that's great. But if nobody can do something with the output, it's useless output. Or it's there for attestation purposes, which means that later on a auditor or a compliance officer or your security team can look at something and say, oh, we're doing the right thing because we have these attestations, which is also an actual outcome. So that kind of brings me into, if I have a pipeline and it breaks, it needs to tell me why it broke. Somebody shouldn't have to go in and go spelunking and finding the needle in the haystack and figuring out, like, why did this break? What happened here? Going through millions lines of logs and figuring out what is the difference of what happened before. So you need to be very concise and very precise and meticulous about what you're sending someone. So that's a very important component there as well. If you don't do that, it becomes, like Gopal showed earlier, you get this five-hour lull in the process where somebody's trying to figure out why something broke and eventually says, I don't know, it didn't break, let's just deploy it, which is not valuable, right? Because you're holding up the pipeline, you're holding up the process, and you haven't figured out what went wrong. That's a very important component as well. And then from a DevSecOps perspective, you need to participate. Like I mentioned earlier, these people have to do something with their hands on the keyboard and create value. I think what we're seeing historically, and I'm going to be blasphemous in the church, as the Dutch would say it. Security people are distant from the operational aspect of the implementation of their security. Often, not all of them, but often. Which means that they have an opinion, but don't participate in implementing the solution. And I think we need to move away from that. That's one. And two is we need to move to a trust but verify model. So security needs to be more minded of the ideology, like we guide people in the right direction, we help them in the right direction. And if they derail, we tap them back onto the rails. So we create guardrails and gates to make sure people are doing the right things. And if they're not staying between the guardrails, they hit a gate. And that gate will tell them, like, hey, you need to change something or do something to actually pass the gate. And that gate might be a manual operation that somebody from security is observing what you're doing, or says, oh, actually, this is okay what you're doing. We allow this. But those are really important components.
Thank you.
And then, that kind of brings you to the last bit. If you want velocity, you need to reduce friction. And that's the guardrails and gates discussion that I was talking about earlier.
Thank you, Fons. Moving on to the next question. So I think this is also one of Vijay from one of the audience asked the same question, is what is the role of automation and machine learning in the security process? I think it's a fascinating question. Primarily because OpsMX, by the way, those of you who don't know, OpsMX originally was Devops MX, which is DevOps machine, and so that's the machine, the AI in the name, and the role of let me give you my perspective, and then I want to ask for your perspective. As Fons was saying that. At the end of the day, there is a lot of log information. There's a lot of information that is getting generated in the process of going from code to deploy. There is a lot of process. There's a lot, and all the three pillars that we talked about, both in terms of security, making sure that all the three pillars we talked about is generating a lot of data, and the machine learning can be at a very high level is useful for in all three aspects. Right? I mean, I think that's, but I won't get into all of them. Right? I think the simplest way I think about is there's a human that is doing the task today, and they're getting a bunch of data, and they're using domain knowledge. Now, as a human processes it, he has some domain insight and a before and after, and a set of rules that the governance has to meet. Right? So the human, whatever the human is doing to process that information and learn that and do before and after can be automated through machine learning. Right? I mean, that's sort of the extremely higher level goal. Now we at OpsMX, what we do is at some of the places, especially during the test, deploy, during production, during deployed, in production, there are things that we look for, use machine learning to help those three pillars get more fortified and more automated. And that's my higher level, but Fons, go ahead, give me your perspective, and then I'll jump back in.
I mean, you touched upon a really important point there that I want to double click on, because you were talking about the humans, right? And as you know, I love humans, but as long as they're not doing manual stuff all the time.
do you really love humans, Fons?
We went out drinking a couple of times, right? I mean, I really love humans. I do. But you were touching upon a really important point there. You're talking about all this information, all this data, right, that's coming to someone. If we look at that deploy pipeline or at that whole process, and somebody needs to make a tangible decision, is this okay or not? And I think if you look at humans, we can only hold a finite amount of information in a little noggin here. I mean, we can only oversee so much. And then there's this bias we have for what we think we know. And that's a dangerous part, right? We think we know something, and that's therefore we look at certain things. But that's why we miss a lot of other things. And I think to your point, right, if we look at what machine learning brings, it brings aspects that we normally would not look at. And it looks at those aspects and tells us hey, there's something weird here. There's something that usually doesn't happen and it's happening. And I think that's really powerful. I mean, I just want to double click on that, because that's, to me, that is like the holy grail, right? If you can light something out and show something to someone that they'd never realized, that where it's like, oh my God, this could have gone horribly wrong if we put this in production, and they would never have noticed. And I think that is a real powerful thing. I mean, if we talk about machine learning, that's, to me, that is the key thing, right? All those metrics, all those logs, and inferring that, and then making a tangible score or analysis of what the outcome should be, and if that outcome is what you expect it to be. I mean, I just wanted to double click, because I think that is, and I think I jumped ahead to like 0.3 now, but and maybe 0.4, anomaly detection, root cause analysis, because that is one of the key things I was talking about earlier, finding a needle in the haystack. I mean, we see it on a daily basis with customers. I've seen it in the past where SREs, DevOps engineers, developers are looking at hundreds of lines of code, thousands of lines of code, and trying to figure out where did it go wrong? What happened? Is it going wrong? Is it doing what it's supposed to do? And the difficulty with that is, if you have a lot of experience with applications, you'll find, and application engineers and developers, you'll find that every development group has their own standards on how they like to log and what that's supposed to look like. So there are groups that will happily, pump out a bunch of things that look like errors to someone else, but to them it's like, oh, that's just, information we vent from the system. And that it's disconnecting and connecting, or that it has a connection error, is not a problem because it solves it itself. But to someone who's a untrained onlooker and not aware of the intricacies of that development group, it would look like the application is performing horribly and it's doing all the wrong things. And I think that is also a thing that if you want to have a unbiased view on how something is performing, it's sometimes not good to have a fresh pair of eyes from a human look at it, but have an analysis from a system that actually tells no, it's behaving within spec. It's doing what it always does. This is normal. And we have examples of that, right, Gopal? I mean, we've seen that with multiple customers. I mean, yeah, sorry.
One question came in from the audience that I'd like to interject here. It seems appropriate. And that is, how long does it take to build the model that you just mentioned? And does your product, OpsumX Enterprise for Spinnaker, come with these models built in?
Yeah, so let me take that question. I think it's from Vijay. The OpsumX Enterprise for Spinnaker comes with a layer of intelligence on top of Spinnaker. And we also have that layer that layer of intelligence works independent of Spinnaker also. So if you have, let's say, Jenkins or Argo CD or other sort of platforms, we do that's at a very high level. And in terms of the machine learning itself, yes, that comes with models. And as Fons was saying, you know, when an application gets deployed, that application is very unique. And so we need to learn about that application characteristics. And so it's not that we do give a seed, but and so an application itself is more complex than just a piece of code that you wrote. It has libraries and all that stuff. So there is stuff that comes in, and we give all of that. But there's a layer that is most important, that is very specific to you and you alone, the way you logged, all of that, that needs to get learned. And that's the fundamental, what keeps us excited at OpsumX, right? And so we've designed the system that it learns through the data by observation for release after release, but also gets human to give you input, because it's very interesting how humans can give very subtle input and the system can learn. Right? And then obviously there is the seed data that comes because we look at a lot of other patterns, right? Vijay, this is a longer conversation, but I kind of want to give you a shorter answer, but happy to take the question a lot more later. Pete, can we keep going? Yeah. Yeah.
So this question is, we've talked about some theory and some frameworks and some best practices, but come back to the reality. What are some of the takeaways that you found from actual implementations, and hopefully successful implementations, but also if there have been challenges that you've run into?
Perfect. So let me give my perspective, and then I'll hand it over to this human-hating guy, Fons. And this also relates to what Ram was asking. One of the attendees was asking a question, is that ultimately we can boil the ocean, right? And ultimately you can't just say, I'm going to remove the human out. So OpsumX, what we've realized is that you have to first automate. Instead of, we think about, don't put an automated gate, but put a semi-automated gate. Meaning that, again, there's a customer of ours who, when they deploy, they take about 3.6 hours to do deployment verification. And there's like there's an app engineer, there's an SRE all together in the weekend, right? And we reduce that to 10 minutes and we also noticed that 75% of the time, you actually don't need even 10 minutes. It's just obvious, either it failed or it passed, right? And there's a gray zone. And so you should always start with something that is trustable and verifiable by you. You have to get confidence, your security has to get confidence, and that is a key takeaway from working with lots of customers. Don't boil the ocean. Start with something small. Start with something that says, okay, I'm going to help you go from 3.6 hours to even half an hour. That's great, right? And so then you will start sort of realizing you start optimizing, and then you'll get into a fully automated state, right? I mean, if there's no that's my one key takeaway, and I'll give it back to Fons to comment more.
Very solid points, Gopal. Really, that's definitely. I mean, we all see the same thing, right? I mean, so one of the key things that I also encountered is that when people start building pipelines, that there is some ambiguity of who owns the pipeline. I mean, we actually help customers build pipelines because some of them we're educating them, we're helping them, understand how it works. We're giving them tools. OES is a huge toolbox, which is really powerful. But there's a lot of guidance and handholding sometimes, and we see that people get confused over who owns the pipeline and who gets to do what. So a pipeline fails, and everybody just stands around and goes like this, and it's like, "Hey guys, there's a message in Slack that the pipeline failed." And it's like, well, yeah, okay, but somebody needs to go in and click the link to see what broke. So it's really important to kind of get to a point where you say, this group or these people are responsible for the pipeline being green all the time. A company I'm very familiar with in the Netherlands, in Amsterdam, where I was before, had the notion of a sheriff. So every day the sheriff would change, somebody else would be the sheriff. And the sheriff's only goal was to make the build green. It didn't matter how, if he had to do it himself, go to people and whip them or, hold them at gunpoint. But his sole job that day was to keep, or week, I think it was week actually, was to keep the build green. And you should do the same for a pipeline. A pipeline is an indicator if you can deliver viable business functionality to the business. If it's not deploying, you're not adding value to the business. It's a business function. So it should always be green, or it should always be able to deploy, or it should always be deploying. If it's not, there needs to be someone responsible to whip the right people to make sure it goes green. And we're seeing that on multiple areas. And I've seen that in the past a lot, that, they kind of walk away and wavy handy thing where people don't take responsibility for it. So that's a really important thing, I think. Then that kind of folds into the fear of the pipeline, where people kind of go like, well, it broke and I don't know how it broke. It's like, well, you can just look at where it broke and you can analyze why it broke and you can fix why it broke. And that's a really important thing, that people educate themselves on, hey, how does this actually work? How do I interact with it? And that's something we do as well. We educate people on like, hey, you can just click here, you can click here, you can pull the log here, you can see what it's doing. Oh, something was missing here. So it's really important to get to that educational point that people stop fearing it. And that is also a part of it, that people that fear the pipeline don't add value to the pipeline. So they won't expand the pipeline and evolve it. And it kind of folds into like the fourth point. Pipelines are like Lego. If you think about pipelines, they're all little Lego blocks, and you can make them really complex, you can make them really simple, you can tie multiple together, but it's important that you observe it like a Lego box. It's not something you break and it's broken forever. No, you can fix it again, you can change it, and you can morph it. And the difficult thing there is that people believe that there's an end state always. I mean, we have this discussion with architects often. Can you document the pipeline for us? It's like, can you make a Visio from the pipeline? It's like, well, it's different every day. So you can go into the UI, you can see the pipeline. It's stored in an S3 bucket or in Git. You can observe the changes there. So it's all there. Yeah, but I really like a Visio. And that means that somebody has to go in and manually maintain a Visio every day, which is ridiculous, right? So I think people need to get to the notion that it's something that's in flux and changes, and it's well guarded because it's maintained somewhere and it's traceable. So I think you have all the elements you want, but people need to understand that that's the way it works. I think that's a really important thing. Then the hybrid teams kind of folds into the initial thing I was talking about, where you have the security team that says, well, you have to do things this way, or you have to have this, and then kind of walk away and let people to their own device. So what I used to do in the past was put a security person in a team, in a DevOps team. And a security person needs to add value to the team, as in hands on a keyboard, or guide the SRE in the right direction to have the right outcome there, which is a very important thing. So the mix of DevOps, SRE, and security, and DevOps obviously being an operations or dev person, because what we tend to see as well is if the pipeline breaks, for example, it might be the software that broke it, some testing in the software. So what if the developer is not in the loop there? So that means that someone needs to go and investigate, and eventually go back to the developer and go, hey, your stuff broke. So it's very important to have those disciplines together and observing the pipeline and knowing who's responsible for which part and why. Then embracing policy as code and define the rules of the game. I think we touched upon that earlier. If we look at people building pipelines, initially it's kind of the wild, wild west, so to speak. Everybody kind of does stuff and puts stuff in, and it's really cool, and it's really fun. But if you're deploying things to production in regulated environments, it's really important to figure out, well, who's deploying what, when, and where, and why. So is somebody who did a PR and kind of merged their own PR allowed to deploy to production? Well, no, for example. And that's a policy you could implement, right? That is a policy. For example, JSOX demands that you can't do that, for example. And I think SOC 2 Type 2 has one of those rules as well somewhere, and ISO something has. So there's definitely rules from a policy perspective. If you want to be compliant, you have to embrace policy as code and define those things in a policy as code. We carry some of those things in OES, but they're extensible and extendable. And you can just add policies wherever you want and guide that pipeline in the right direction. And also have tangible output where it tells people, hey, buddy, you can't merge your own, you can't merge your own PR and then expect it to be deployed. That's not how the system works. So you can actually give that message back to the developer, so you can go back and tap someone else on the shoulder, hey, buddy, could you merge my PR so I can actually go into production? So it's, that's also part of the education story, where you have to take people by the hand and help them. And the system needs to do that inherently. So the system needs to be descriptive and create these guardrails leading either to gates or to the outcome of deploying your software. And I think that's kind of the notion of educating people on pipeline thinking. That's kind of the end of the story. And this is something we deal with on a daily basis, like all of these points.
Thank you, Fons. And thank you, everybody, for attending this fireside chat. I think there was a couple of questions here. And if you are interested in, I think Ram was asking about 2-3 native use cases for ML. We don't have time to cover this, but happy to follow up. But if I were to just bring it back home, I think those 3 pillars of both the making sure the delivery is secure, the artifact that is being delivered is secure, and having observability and auditability and traceability, I think that what I'm realizing as I'm talking to customers is it's the rate at which the speed and scale of releases is increasing, just phenomenal. So I just worry that if you don't have a proper start thinking about security, it's going to be a disaster that could potentially happen. And that's why we wanted to start this sort of a fireside chat. And if there's any, to the attendees, if there's any way we can help answer your questions, feel free to reach out to us. Me and Fons and anybody at OpsMX can help. Thank you.
If you do have questions, feel free to contact us through this last poll. And just indicate the first one. There are some security issues where that should say where I would like your advice. Or if you'd like to do something that's in more detail, we do have a complimentary continuous delivery security workshop. So feel free to indicate yes on these, or drop us information, or drop us a question at info@opsmx.io. I'd also like to say thank you very much to Fons and Gopal for allowing us to publish their email addresses. If you have questions, follow up with them, go for it. And if you have any questions, again, for OpsMX in general, info@opsmx.io. Thank you very much. We really appreciate it. And I hope that you have a great day.
Thank you.